Welcome to my channel, STEM Cafe, where I make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, and entertaining. Today we'll deal with centroid or center of mass, or gravity, or composite or complex bodies. You know, ordinarily, this topic, centroid or center of mass or whatever, is the topic mainly under moments. Moments. But because while we are treating calculus, we came to it, and that is why I would like to treat it further, so that we will really deal with it fully, and not say, oh, we've dealt with a part and then forget the other part. Calculus is used to get the centroid or center of mass of gravity of different shapes. But when we are having these bodies having different shapes joined together, that is what I'm about to discuss today, so that it won't be anything, like difficult. To be fun, as our major motto here. When we have, as I told you, the main thing about centroid or center of mass is from moments. So when you are dealing with this, you can see even in derivation of the centroid, we take moments of elemental parts, and then we do the summation of everything. Now, when we are having different shapes, let's say we have a composite shape like this. What do? We can break the shape down like this. And since we know the moment, the center of gravity, or centroid of this one, we locate it. The center of gravity of this one, we locate it. And then what do? We find the moments about this place. This one too, we find the moments about this place. So let's say this is area A1, area A2. The center of, or centroid of this one, let's call this one X1. The centroid of this one, let's call this one X2. Once you have done that, we will now say, okay, total mass will be equal to A1 plus A2. Total moments will be equal to X1 A1 plus X2 A2. You can see. And from there, we can now say the center of gravity or centroid of the whole shape is going to be total moment over total mass, which will be X1 A1 plus X2 A2 divided by A1 plus A2. Simple. Now, for this same shape, we can break it into two again. We can say like this. This one is A1, this one is A2. What will be the centroid of this one? We know what it is. It might be here. The centroid of this one, it might be here. So let's call this one X1. Let's call this one X2. So the calculation still goes in the same way. So either way you take it, just take your moment. The same thing if you want to take it for this part. So now, look at it. When I want to take the moment about the x-axis, see, y, a1, y1, a2, y2. So at the end of the day, the mass still remains the same. Oh, I think I changed it now. So at the end, you are going to have y1, a1, y2, a2 over a1 plus a2. So you can see, it is a very easy thing. The most important thing is you must have the basic knowledge of what the centroid of each shape is. That's the only way you can do it. And then you must be able to calculate the distance of the centroid or center of mass or center of gravity of each shape from the axis you are taking the moment about. Let's look at one or two examples. Oh, before we go on, let me show you another one. So looking at this place is a whole ball, a cut-out shape from the whole shape of a rectangle. So let's call the shape, the area of the whole shape, area of O is equal to A1. Area cut out is equal to A2. You can see. Now, the centroid, you must locate the centroid of A1 as if this was not cut out of it, because you are trying to locate the centroid of the whole shape after this one has been cut out of it. So let's say the centroid of this one is X1. So, and the centroid Now look at the centroid of the cutout space. This one, let's call it x2. So because this one is cut out now, you can see that the total area or mass or volume or whatever is going to be A1 minus A2. You can see. Now total moment will be equal to A1 x1 minus A2 x2. You understand now? Minus A2 x2. Then we are going to have our centroid of the whole remaining shape will be equal to total moment over total mass, which will be equal to A1 x1 minus A2 x2 divided by A1 minus A2. So that is all. Just know this. You can do any composite shape. You'll be able to undo this for it. So as we finish this, I will just show you how to. Probably I will work out the centroid of different shapes later on. Now look at this simple body. Let us get the centroid of this shape. For us to find it very easy, you might cut it like this. You might cut it like this. For me, I decided to cut it like this so that I just take my moment about this place straight, easily. For this point here, the CG or centroid is 1 meter from the y-axis. Are you seeing? For this one, the centroid for this lower one is 2 meter from the y-axis. You can see. And if I should just get this one now, for this one now, from this place to this place is 0.5. You can see for this one. So 0.5 plus 1, so it's going to be 1.5 here. So the moment of the centroid of this place is 1, 1.5. 1, 1.5. For this one too, the centroid is going to be from here to here. That is 0.5. From here to here is 2. So we have 2, 0.5. You can see. So all these ones are in meters. Now let's cut it into. We have said that this place will be A1 and this place will be A2. Let's calculate what A1 is. Area A1 is equal to 2 times 1. This is 2. This is 2 times 1. 2 times 1, which is 2 meters squared. Area A2 is equal to 4 times 1. 4 times 1, which is 4 meters squared. Now let's arrange everything in table for ease. So for ease, I have arranged it in table. So this is shape 1, shape 2. So this is shape 1, shape 2. A1, A2, X for 1. So these are the centroids. These are the moments about each axis. Moment about axis Y, this is it. Moment about axis X, this is it. So now let's find the centroid along the X and Y direction. So for our X now, it's going to be total moments about y-axis divided by total mass or total area, sorry, and that is going to be 10 divided by 6, which is 5 over 3. That's going to be 1.67 meters. For y, that is total moment about x-axis over total area, and that's going to be, so this is going to be 0.833 meters. So you can see it is very simple. The only thing is locating the centroid and then taking the moment using the centroid, because all the area in this instance or mass or whatever is taken to be concentrated at the centroid or center of gravity of mass. So that's how it is done. Very simple, direct. Let's look at another one. Now look at this composite body on the board. And we are asked to find the centroid of the whole shape. It's composed of triangle, rectangle, and semicircle. For all of this, there is a way of getting each centroid. For the triangle, the centroid from the base is 1/3 of the height. For the semicircle, the centroid from the diameter is 4r over 3 pi. So which means that the centroid here for this one is 4 times 1.5 over 3 pi. So this is going to be 4 times 1.5 over 3 pi. And what does that give us? 2 over pi. So that is the centroid of this one from this, from the axis, x-axis. That is the centroid for this one. For this one here, and from here to here, we know it's going to be r. So this is going to be 1.5. You can see. So we have it as for this place now, it's going to be 2 over pi and then 1.5. No. For this one now, it's going to be 1.5, 2 over pi. That is the centroid for this one. But because it is below the x-axis, this one is going to have minus in front of it. Now let's deal with this one. For this rectangle, we can see that the centroid from this place to this place, if you look at this place, it's going to be 3. So it's going to be 1.5, just like this one, 1.5. And from this place to this place, because this is 2, it's going to be 1. So we have solved this one. Because this is not a right, what's it called? Triangle. Right angle triangle. I'd rather it is cut into 2. You can see. And then the centroid now, for this part, we get it separately. For this one, we get it separately. So that we'll be able to work everything straight at once. And if it is isosceles triangle, it will have been it will have been better. But now it's not isosceles, neither is it right angle. So let's break it into 2 right angle triangles. So for this one here now, from here to here is 2. So it means that from here to here will be 2 over 3. And from here to here again is going to be 2 over 3. You can see. So how will that pan now? It means that from this place to this place is going to be 2 plus 2 over 3. That is the y-axis. Same thing for this one, 2, and that is 8 over 3. So 8 over 3, 8 over 3. Now, from this place to this place, it's going to be 2 minus 2 over 3. Because from here to here now, it's going to be 2 over 3. You understand me now? Because this is the triangle now. And from here to here is 2/3. 2/3 of this place. So from here to here, from here to here, is 2/3 of this place. So this place will be 2 over 3 times 2. So this place for me now, I'm going to have it as 4 over 3. Please forgive me. From this place to this place is going to be 2 over 3. Since from here to here will be 1 over 3 of the height. From this place to this place is going to be 2 over 3. Now, from this place to this place is going to be 1 over 3 of this place. And you know that from here to here is 1. So what does that give me? It means that it's going to be 2 plus 1 over 3. So that place is going to be 2 plus 1 over 3. Please take notes. It's going to be something like this. From this is 0.2. So from here to here is 1 over 3 times 1. So it's going to be 2 plus 1 over 3, which is 7 over 3. So I'm going to have here 7 over 3. So I believe it is now easier to handle. We have shape 1, shape 2, shape 3, shape 4. Now let's do something else. For this one, area of each, let's find it. A1 is going to be half base, which is 2, times height, which is 2. And that is going to be 2 meters squared. A2 is going to be half times base times height. What does that give us? 1 meter squared. For this one, A3, what does that give us? 2 times 3. 6 meters squared. For the last one, that is A4. And then for the last part, A4 is equal to half, because it is semicircle, you can see, times pi times 1.5 squared and that is 2.25 pi over 2 meters squared. So I have found the areas, I have detected the centroid of each shape. Now let us find the centroid and yes, of the whole shape. Now with this, I like making it in table form. You might not make it in table form, you can stretch it out depending on how you like it. You understand? So with this, we can easily do it. These are the moments. These are the moments. So we can do it like this now and say x is equal to total moment about y axis over total area. And let's find that. Let's use our calculator. This is the total area here. Total AX. And this is total AY. So we can see, and that's going to be total AX over total A. And let me use calculator to find it. So you can see, this is what I got using the calculator, approximately. Let me go to approximately 1.54 meters. Now let me calculate y. So you can see, y will be total moment about x-axis over total area, and that is this over this. Now let's quickly do that. So, and that is 0.9374 meters. So our centroid is 1.54 meters, 0.9374. So you can see how simple it is to handle. So to conclude, I would like to do one more exercise. Now we have this. A square plate of side 120 mm has a hole of radius 40 mm, has a hole of radius 40 mm bored in it. The center of the hole lies on the diagonal and is 40 millimeter from the center of the square. Find the position of the CG of the remainder. Now, this is very easy to handle. I already brought this up so that you will look at when we have it bored. Now, that is when there is hole in it. Let's make this one our x-axis and this place our y-axis. For the whole shape, the center or the centroid will be 60 by 60. 60 from the x-axis, 60 from the y-axis. 40 mm here. That is the center of this circle. So to locate this place now, it's going to be, this place is 60, 60. So to locate this place now, it's going to be, and as you have seen, this is a square. This place is going to be 45 degrees. So this place is going to be 60 plus 40 cos 45. At the same time, this place is going to be 60 plus 40 sine 45. So the centroid of this board circle is 60 plus 40 cos 45, 60 plus 40 sine 45. So now, for the whole square, the centroid is 60, 60. For the board circle, the centroid is 60 plus 20 root 2 and 60 plus 20 root 2. So you can see, we can now work everything out now. Area for the whole shape is 120 square. Area 120 square. Area for the board circle is pi 40 square. So from there, we can make a table or we can do everything straight. Let's make it. So now everything is now made into table form. Area, the centroid, and the moments. Now let's find the moment of the whole shape now. For x, it's going to be moment about y-axis, total moment about y-axis over total area. And what is that going to be? It's going to be this one minus this one over this one minus this one. So you are going to have 60 times 120 squared minus pi 40 squared into 60 plus 20 root 2 divided by 120 squared minus pi 40 squared. So since I'm using calculator, I have no headache. Let's use it straight. So our x-axis is 44.8325 millimeters. Let's find the y-axis as well. So for the y-axis as well, it's the same thing. 60 times 1 to 20 square minus 540 square by 120 minus 540 square. So it gives me 44.8325 as well. So it's going, which means that this new centroid is going to be around this place. It's going to be around here. And it's even on the diagonal. So our x is equal to 44.8325. Our y-axis, as in the centroid, is 44 millimeters. 44.8325 millimeters. So that's the answer. So what I've just tried to show you is to know the principle of handling the centroid. Thank you. Kindly share, subscribe if you haven't, make comments, make inquiries, please. Let us know any other topic you are interested in. I don't just want to come around and start doing anything. I'm here for you. Let this thing go viral. Thank you for your support so far. I appreciate you all. Thank you very much.